Welcome to PROCAD's 3DSMART piping application software. Let's look at the supporting modules included. Double-click the Component Designer icon to open it. Component Designer is a powerful tool that expands your design capabilities. By combining the flexibility of 3DSMART graphics and the functionality of an SQL Server database, you can edit libraries and components, add new component sizes, or revise dimensional data of existing ones. You can create complete new libraries. You can decide design rules to be applied to each component, and you can define the post-processing of your data, such as including it in bill of materials. Let's explore the basic screen layout. At the top is a standard menu bar, allowing access to features of the software, as well as the toolbar, which allows us to set some of the settings and access some of the features, things like the dimensional sizes. On the left is the Work Tools window pane, which gives access to the different modules within the Component Designer. The next pane over is the navigation pane, showing a treed structure of the libraries, components, and groups. The next pane over from that is the data pane, showing detail about the information selected in the navigation pane. And then finally, the 3D view, showing a 3D visual of the component. Basic zoom, pan, and orbit features are allowed. Right-click in the window to access these options. All panes can be moved and resized. Component Designer consists of 4 major modules covering all the steps in the component creation process. Let's look at each one in more detail. The first module is the Library Design module. Library Design module allows us to access different features about the different libraries within the software. For instance, we have the ANSI piping, ASME piping, equipment, shared components, and structural steel. Tab menus are also considered part of a library. Let's take a look at some of the library information. Taking a look at the ANSI piping, we can see component properties, property tables, component types, component metadata, and size assemblies. Let's take a closer look at the component types. We'll look at the 90-degree long radius elbow as a sample. The lock feature that you see beside each icon represents a locked database component that comes standard with PROCAD software and cannot be deleted. We finally get down to a treat area where we see red cubes. Taking a look at the groupings, we'll open up a Schedule 40 to take a closer look. Under the Components tab, we see all available pipe sizes denoted by a purple cube. The descriptions are what would show up if we ran a bill of material. If we want to see more information about the actual data, we can go to the Component Grid tab, and this displays the actual dimensional values for each of the components for each of the sizes. We'll close this information off and look at the next module. Under the Tools, we'll see Design Systems. The Design Systems module is used to group similar components and assign conditions like mating faces. Let's look at the piping system and the ANSI piping group for a sample. Under mating faces, we can see different features and settings for the components. You can click on the Connectivity tab, and we can take a look at a sample here of using a gasket, raised-faced. If we come across, we notice that the X is on, which means it is able to connect with a raised face flange. So in the 3D modeler, when we place a flange and gasket, they will allow connectivity. Let's take a look now at the Metadata Builder. Under this tab shows all the components and all the metadata. The Metadata Builder is a scripting language used to create components into 3D objects with specific shapes. The data is connected to the library, group, and component and can be seen in real time in the 3D window. If you can draw it in AutoCAD, you can create it with the Metadata Builder. We'll look at the metadata used to create the 90-degree elbow. The metadata for the elbow is broken down into 5 sub-areas. We have the parameters, which set default parameters about the size and dimensional data for the component. We have the declarations, which are variables created using the parameters to simplify and calculate needed values. We have the 3D points, which are definitions using absolute, relative, and XYZ point filters to define the shape of the component. The insert point are the connection points used when inserting the object in the 3D modeler. As shown on the view, we can have connection points at different locations on the component, and there can be more than one. These insertion points can be inserted as macros. And then finally, we have the 3D entities, which are the actual routines to create the component, using functions like union, subtract, extrude, revolve, functions that are used in AutoCAD that we can define within the Metadata Builder. At the bottom is an error detection section, so when we go to validate our values, if any errors were to show up, it would list it in this area. The preview button allows us to take a look at the component as we're building it, so we can see it in real time. The last module to look at is the menu editor. It is used to update existing menus or create new menus when a new library or component has been created. We'll load an existing menu. The ANSI piping. Again, we'll use a 90-degree butt welded long radius elbow as an example. We click on the elbow once, it is highlighted in red, and all the information about the tool is shown in our data pane. We double-click the icon. It takes us into the icon editor, where we can actually graphically change what the item looks like. Make sure to save. We can also test the menu to see if it's going to work. Pick it, and it tells us that it's going to place the component. And we can even test the item itself. We can set some of the sizes, let's say 4-inch. Let's go with spec A, 150 pound, run the test. And it brings up what you would see in the 3D modeler. Remember to save your changes. Lastly, to exit the component designer, File menu, and exit. It's that easy.